To determine the service calculation for two uninterruptible power supply or systems powering a load with dual power inputs, it's important to consider the redundancy aspect. Each UPS system has a nameplate rating of 80 kilowatts, and when both are online, they each supply 40 kilowatts to the load, totaling 80 kilowatts. If one UPS fails, the other takes over the entire 80 kilowatt load. In this scenario, the service calculation should be based on the maximum potential demand. Since each UPS requires its own power input to maintain redundancy, you should use two breakers, each size for 80 kilowatts. This ensures that each UPS can operate at its full capacity if necessary. The total service calculation, therefore, is 160 kilowatts. This approach guarantees that there's enough power available to support the load under any condition, whether both UPS systems are running or only one is operational. Now, regarding whether you can treat an 80 kilowatt UPS as a 40 kilowatt UPS if you only install 40 kilowatts worth of batteries, the answer is no. The nameplate rating of the UPS, which is 80 kilowatts, indicates its maximum power capacity. Installing only 40 kilowatts worth of batteries will limit the runtime of the UPS during a power outage. The UPS can still provide 80 kilowatts of power, but it will drain the batteries more quickly than if it had the full 80 kilowatts worth of batteries. Insufficient batteries increase the risk of the load losing power during an extended outage. The battery capacity is directly related to the backup time the UPS can provide at a given load. If you install only half the batteries, the runtime will be significantly reduced. To properly size a UPS and its battery system, consider these factors. Firstly, load requirements. Determine the total power needed to support all connected equipment during a power outage. This includes both the current load and any potential future expansion. Secondly, runtime requirements. Determine how long the UPS needs to provide backup power. This depends on factors such as the frequency and duration of power outages in the area, the time needed to safely shut down equipment, and the availability of backup generators. Thirdly, UPS capacity. Select a UPS with a power rating that is greater than or equal to the total load requirements. It's generally recommended to choose a UPS with some extra capacity to account for future growth and to avoid overloading the UPS. Fourthly, battery capacity. Calculate the required battery capacity based on the load requirements and the desired runtime. Battery capacity is typically measured in amp hours. To calculate the required amp hours, use the following formula: amp hours equals the load in watts multiplied by the desired runtime in hours, divided by the battery voltage and the depth of discharge. Fifthly, battery type. Choose the appropriate battery type for the UPS. Common battery types include lead-acid batteries, which are less expensive but have a shorter lifespan, and lithium-ion batteries, which are more expensive but have a longer lifespan and higher energy density. Sixthly, environmental conditions. Consider the environmental conditions in which the UPS will be operating. Temperature, humidity, and altitude can all affect battery performance and lifespan. 7. Maintenance requirements. Establish a regular maintenance schedule for the UPS and batteries. This includes checking battery voltage, cleaning the UPS, and replacing batteries as needed. 8. Redundancy and scalability. For critical applications, consider using redundant UPS systems to provide additional protection against power outages. Also, choose a UPS system that can be easily scaled to accommodate future growth. Remember that the battery capacity is directly related to the backup time the UPS can provide at a given load. To determine the appropriate battery size, use the following calculation. Ampere hours equals watts times hours divided by volts times efficiency. The watts is the load that the UPS will be supporting, the hours is the amount of runtime you are looking for, the volts is the battery voltage of the UPS, and the efficiency is the efficiency of the inverter, which converts the direct current power of the batteries to the alternating current power that powers your equipment. Here's an example. Let's say the UPS has a load of 40,000 watts, a desired runtime of 1 hour, a battery voltage of 480 volts, and an inverter efficiency of 90%, or 0.9. The required battery size is 40,000 times 1 divided by 480 times 0.9, which equals approximately 92.6 ampere-hours. Therefore, you would need to install batteries with a capacity of at least 92.6 ampere-hours to meet your runtime requirements. It's always a good idea to round up to the nearest standard battery size to ensure that you have sufficient capacity. In general, it is best practice to size the batteries for the full nameplate rating of the UPS even if the current load is less. This provides future scalability and ensures that the UPS can handle any unexpected load increases. Additionally, oversizing the batteries can improve their lifespan and reduce the risk of failure. UPS systems are designed to provide a reliable source of power during power outages, protecting sensitive electronic equipment from damage and preventing data loss. Understanding the principles of UPS operation and proper sizing is essential for ensuring that the UPS can meet the specific needs of the application. There are three main types of UPS systems. Firstly, offline or standby UPS. Secondly, line interactive UPS. And thirdly, online or double conversion UPS. Firstly, offline or standby UPS systems are the simplest and least expensive type of UPS. In normal operation, the load is powered directly from the mains power supply. When a power outage occurs, the UPS switches to battery power. The switching time is typically a few milliseconds, which may be long enough to cause some sensitive equipment to lose power or experience a brief interruption. Secondly, line interactive UPS systems are similar to offline UPS systems, but they include a voltage regulation circuit that can correct minor voltage fluctuations in the mains power supply. This helps to protect the load from voltage surges and sags. Line interactive UPS systems also have a faster switching time than offline UPS systems, typically less than 4 milliseconds. Thirdly, online or double conversion UPS systems are the most sophisticated and expensive type of UPS. In normal operation, the mains power supply is first converted to direct current, then converted back to alternating current. This provides a clean, stable source of power to the load, regardless of the quality of the mains power supply. Online UPS systems have no switching time, so the load is never interrupted during a power outage. The selection of the appropriate UPS topology will depend on the sensitivity of the equipment it is designed to protect and the power quality requirements. In addition to the core functionality of providing backup power, UPS systems also offer a variety of other features and benefits. These include firstly, surge protection. UPS systems typically include surge protection circuitry that can protect the load from voltage spikes and surges. Secondly, voltage regulation. UPS systems can regulate the voltage of the mains power supply, ensuring that the load receives a stable voltage. Thirdly, power conditioning. UPS systems can filter out noise and other disturbances from the mains power supply, providing a clean source of power to the load. Fourthly, remote monitoring and control. Many UPS systems can be remotely monitored and controlled, allowing administrators to track the UPS status, receive alerts, and perform maintenance tasks. Fifthly, automatic shutdown. UPS systems can automatically shut down connected equipment in the event of a power outage, preventing data loss and equipment damage. When selecting a UPS system, it is important to consider the specific needs of the application. Factors to consider include firstly, power requirements. The UPS should have a power rating that is sufficient to support the load. Secondly, runtime requirements. The UPS should be able to provide backup power for the desired amount of time. Thirdly, topology. The UPS topology should be appropriate for the sensitivity of the load. Fourthly, features. The UPS should have the features that are needed for the application. Fifthly, cost. The UPS should be affordable and provide a good value for the money. Finally, understanding the basics of UPS sizing and battery capacity is essential for ensuring that your UPS system can provide reliable backup power when you need it most. By carefully considering the factors outlined above, you can select a UPS system that meets your specific requirements and protects your valuable equipment. Also, consider that the NEC, or National Electrical Code, provides guidelines for the installation and wiring of UPS systems. Refer to NEC Article 645 for information technology equipment, which covers UPS systems used in computer rooms and similar locations. This article includes requirements for disconnecting means, overcurrent protection, and grounding. When sizing the conductors for a UPS system, refer to NEC Section 310.15, which provides guidelines for determining the ampacity of conductors based on their size, insulation type, and installation method. The ampacity of the conductors must be sufficient to carry the maximum load current of the UPS. Also, consider NEC Section 430 for motor circuits, which is not usually what UPS are connected to, but some UPS may have internal motors for cooling or other purposes, so it's important to understand the requirements for motor circuits. This article covers overcurrent protection, conductor sizing, and disconnecting means for motors. For overcurrent protection, refer to NEC Section 240. This section provides requirements for overcurrent protection devices, such as circuit breakers and fuses. The overcurrent protection devices must be sized to protect the conductors and equipment from overloads and short circuits. For grounding and bonding, refer to NEC Article 250. This article provides requirements for grounding and bonding electrical systems. Proper grounding and bonding are essential for safety and to prevent electrical shock hazards. For surge protection, refer to NEC Section 280. This section provides requirements for surge protection devices, which can protect equipment from voltage spikes and surges. Furthermore, it is essential to consult the UPS manufacturer's specifications for detailed information on the UPS system's electrical requirements, including voltage, current, and power ratings. The manufacturer's specifications will also provide guidance on the proper installation and wiring of the UPS system. Regular maintenance is crucial for ensuring the reliable operation of a UPS system. Maintenance tasks include checking battery voltage, cleaning the UPS, and replacing batteries as needed. Refer to the manufacturer's recommendations for specific maintenance procedures and intervals. Also, qualified personnel should perform all electrical work related to UPS systems. Electrical work can be dangerous, and it's important to have the knowledge and experience to perform the work safely. Always follow all applicable codes and standards when installing and maintaining UPS systems. This will help to ensure the safety and reliability of the electrical system. When dealing with UPS systems, it's important to understand the key electrical concepts. Firstly, voltage. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Secondly, current. Current is the flow of electrical charge through a circuit. It is measured in amperes or amps. Thirdly, power. Power is the rate at which electrical energy is transferred. It is measured in watts or kilowatts. Fourthly, resistance. Resistance is the opposition to the flow of electrical current in a circuit. It is measured in ohms. These are some of the important electrical concepts to consider. Electrical calculations are essential for determining the appropriate size and type of electrical equipment for a given application. Some common electrical calculations include: firstly, calculating the load current. To calculate the load current, divide the power in watts by the voltage in volts. Secondly, calculating the conductor size. To calculate the conductor size, use NEC Table 310.15, which provides ampacity ratings for different types of conductors. Thirdly, calculating the overcurrent protection size. To calculate the overcurrent protection size, use NEC Section 240, which provides requirements for overcurrent protection devices. Fourthly, calculating the grounding conductor size. To calculate the grounding conductor size, use NEC Table 250.122, which provides grounding conductor sizes for different sizes of service entrance conductors. Also, consider that in addition to electrical codes and standards, there are also industry best practices for UPS installation and maintenance. Some of these best practices include: firstly, installing the UPS in a clean, dry, and well-ventilated location. Secondly, providing adequate clearance around the UPS for maintenance and ventilation. Thirdly, using properly sized conductors and overcurrent protection devices. Fourthly, grounding the UPS in accordance with NEC requirements. Fifthly, performing regular maintenance and inspections. Sixthly, keeping accurate records of all maintenance and repairs. By following these best practices, you can help to ensure the reliable operation of your UPS system. Moreover, be aware that there are several safety precautions to follow when working with UPS systems. These precautions include, firstly, always to energize the UPS before performing any maintenance or repairs. Secondly, use appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and insulated tools. Thirdly, follow all lockout-tagout procedures to prevent accidental energization of the UPS. Fourthly, never work on a UPS system alone. Fifthly, be aware of the potential hazards of working with batteries, such as acid spills and electrical shock. Sixthly, dispose of batteries properly in accordance with local regulations. By following these safety precautions, you can help to prevent accidents and injuries when working with UPS systems. Another aspect to consider is the environmental impact of UPS systems. UPS systems can consume a significant amount of energy, especially if they are not properly sized or maintained. To reduce the environmental impact of UPS systems, firstly, choose energy-efficient UPS systems. Secondly, size the UPS system appropriately for the load. Thirdly, maintain the UPS system regularly to ensure optimal performance. Fourthly, consider using renewable energy sources to power the UPS system. Fifthly, dispose of batteries properly in accordance with local regulations. By taking these steps, you can help to reduce the environmental impact of UPS systems. In addition to the technical aspects of UPS systems, it's also important to consider the financial implications. UPS systems can be a significant investment, but they can also save money in the long run by protecting valuable equipment from damage and preventing data loss. To assess the financial impact of a UPS system, firstly, consider the cost of downtime, which is the cost of lost productivity and revenue due to power outages. Secondly, consider the cost of equipment damage, which is the cost of replacing or repairing equipment damaged by power surges or outages. Thirdly, consider the cost of data loss, which is the cost of recreating or recovering lost data. Fourthly, consider the cost of the UPS system, including the initial purchase price, installation costs, and maintenance costs. Fifthly, consider the return on investment, or ROI, which is the ratio of the benefits of the UPS system to the costs. By carefully considering the financial implications, you can make an informed decision about whether or not to invest in a UPS system.